Nope, that's perfect. Okay, so today we're looking at geometry, probability, and statistics. The last time we looked at numbers, quantities, and algebra. So this is the same as I presented last time, so it's review for you, and you're already taking the test tomorrow. But you need a score of 150 to pass the math section in Wisconsin. 56 questions in 85 minutes. Most of them are multiple choice. Some of them are choose all that apply, and some of them have a box where you put in the answer. Calculators are allowed if you use our testing center. If you're going to use a different testing center, please call them in advance to find out what calculators they allow. Our testing center allows scientific calculators. It does not allow graphing calculators. So make sure you have the right kind of calculator, because if you use the calculator on the screen, it eats up a lot of your time. There are 4 types of questions: numbers and quantities, algebra, geometry, probability, and statistics. And today we're going to be looking at these last 2. On Monday we looked at the first 2. This is what ETS, the company that makes Praxis, has published. They have the 85 minutes for the 56 questions, so an average of 1.5 minutes per question. And then they have the breakdown of the questions. 60% of your test is numbers and quantities and algebra, what we did on Monday. 40% of your test is geometry, probability, and statistics. Okay, so let's start looking at geometry.
Now with geometry, I know is it on the ACT,
Yeah, the topics that are covered are very similar to each other between the ACT and the Praxis. Okay, so you need to know vocabulary that applies to geometry. Be able to apply that vocabulary. You need to know about lines, triangles, squares, rectangles, and circles. There are other things like cylinders and cones, and 3D, like pyramids and spheres and cubes. But these are the most important. Make sure that you have these mastered. Once you have these mastered, you can move on to the more difficult ones if you have time and you feel like you can get it. All right, so you guys are sitting by each other. Good. You guys are kind of far apart. Why don't you move back by her? And then, Jake, do you want to be partner with him? So I'd like you guys to talk about what congruence is and what the symbol for congruence is. Do you want to hand out some note cards too, maybe, before you... Okay, so sometimes in a question they're going to say that 2 things are congruent. Does anybody know what that means? Do you want to share? Yes, they're equal. So if 2 things are congruent, they're equal. You can have congruent angles. You can have congruent triangles. How is congruent different than similar if they use the word similar, like these 2 triangles are similar? Yeah.
They won't be equal, but they'll be like there could be a smaller one and then a bigger one, and they'll be similar, but not exactly the same.
Okay, and what does that mean to say they're similar?
Like the size.
Okay. So like the proportions of the sides are going to be the same, but it's like 2 times bigger or 1 time bigger. Okay. Yep. All right. So know the difference between those 2. This is this is the symbol that they'll use for congruence. So the AB line is congruent to the CD line, and then they're drawing those lines to show you. The EF line is congruent to the HG line. And in a triangle, you'll see maybe one side they'll have a line on, and then the other side they'll have a line on. It means that in that triangle, those 2 sides are equal to each other. They're congruent. And that can help you solve a lot of problems to know that. Okay, so it can be used to describe angles or segments of line. Let's look at angles. There can be congruent angles, acute angles. Let's see how many of these I have. Obtuse angles, right angles, complementary angles, supplementary angles, linear angles, vertical angles, and go ahead and talk to each other about what each of those are. If you want to sit close enough to somebody that you can talk, that might help. Did you get all your angles? Oh. Nice. It's all fresh. Okay. So should we go through these? All right. So since we just talked about congruent, what are congruent angles? Two angles that are equal to each other. What is an acute angle? Okay, less than a 90-degree angle. Obtuse.
Larger than 90?
Yep, right. A 90-degree angle. Complementary angles. Yeah, they add up to 90, exactly. Supplementary angles. What is that? Yep. So they add up to 180. Linear angles. Linear angles make a line, so they also are going to add up to 180. So they're a type of supplementary angle. How about vertical angles? Yeah. Perfect. Okay. Is this one of the good markers? Let's try. Oh, it works. So if we have two lines that are intersecting, the opposite angles are called vertical angles. And what do we know about those opposite angles? They're equal, or they're congruent. So if I call this A and this B, angle A and angle B are equal to each other, and angle C and angle D are equal to each other.
So it adds up to 360?
In this case, yes, because you make a whole circle, it would add up to 360. What would A and D add up to? 180. And B and C, of course. So those are linear angles. They're also supplementary angles because they add up to 180.
So supplementary adds up to 180?
Yes. All right, and I think I have a description of vertical angles written here. They're formed by two intersecting lines, and they're always congruent. Okay, so let's go on to triangles. And for triangles, it's really important to know about the interior angles of the triangle, how to find the area of a triangle, and how to find the perimeter of a triangle. So go ahead and talk to each other. What are each of those things? Okay, so let's see what we have. What do the interior angles of a triangle add up to? Does anybody know? So if I have a triangle, I have three angles, right? What do those three angles always add up to?
No, 180.
180. They'll always add up to 180. So that can help you solve a lot of problems, knowing that they always add up to 180. How do I find the area of a triangle? Yeah, go ahead.
You would do base times height divided by 2.
Okay, good. where's the base on here? Where is the height? Talk to each other. You can draw the same diagram and then show me where the base is, show me where the height is. Okay, so did you guys agree where the base and the height are? Okay, so we could call this one the base. The height is going to be to the midpoint. So it would be 1/2 of this base times this height. When I draw this line, what did I just create?
You divided it?
I divided it and I created two what? Two right triangles. So now I've got these right triangles. This side is going to be what? What's the length of that side going to be?
It's going to be cut in half.
Yeah, it's going to be half of that base. So if I knew what this was, I knew it was 3, and I knew this one was, I don't know, let's make it up.
4.
It can't be 4 because it can't be longer than the hypotenuse. So I'm going to say it's 1. Then what can I use to find the height? What is it? The Pythagorean theorem. Anytime you see right triangles, I want it to just snap in your head. They're probably going to ask me to use the Pythagorean theorem somehow. And we are going to go over the Pythagorean theorem, so hold tight. Okay, so interior angles always add up to 180. Area is 1/2 of base times height. Perimeter, you add the length of the 3 sides.
So once we find we would just plug in the, for example, b equals 1 and h equals 3. We just plug those numbers in, and once we get the number, we just go half divided by 3.
So you would do 1/2 the base, which is 1 here in this example. And then you'd have to solve for the height using Pythagorean theorem. So you would have 1/2 base times height. You guys want me to solve for this? It's going to end up being an ugly number because I didn't do anything pretty. But okay, so if I have this right, I'm going to take half of this right here. I said the base is 2, right? Actually, the base should have been 2 because half of the base is 1. I said this one is 3. How do I solve for this? Talk to each other. Okay, so we're using the Pythagorean theorem, which is a squared plus b squared equals c squared. We have a squared, these can be interchanged. They're both legs, it doesn't matter. So 1 squared plus, I'm going to call this one b. I don't know what it is. Plus b squared equals c always has to be the hypotenuse. The hypotenuse is the side opposite the right angle. So c squared is 3 squared. So I end up with 1 squared is 1 plus b squared equals 9. Subtract 1 from both sides. B squared is going to equal 8. B is going to equal square root of 8. So in this equation, like I said, it's not going to be pretty. A is going to equal 1/2 the base, which is 2, times the height, which is the square root of 8. Which is going to be area equals 2 times the square root of 8 over 2, which equals what? Square root of 8. Do you need the plus or minus? Here?
Yeah.
No, because you can't have a negative area.
Okay, so like, it would do that, but it doesn't matter because you can't be negative.
B squared equals the square root of 8. Yeah. Square root of 8. I'm trying to think backwards to see if I could even have that negative square. Possibly. I think about what you're solving for,
Yeah.
and try and solve whether or not it makes sense. So I'm trying to think. Let me think of another example and see if. But I don't think so.
So just to be clear, I just can't plug in the numbers to find the area?
You did plug in the numbers to find the area. Area is 1/2 base times height. Base was this, right?
Yeah.
And half of the base was 1, so the total base is 2.
Yeah.
So 2 times, we solved for the height. The height was the square root of 8. This is this. We just took half of it over there.
If you have the base and the height, then you can just plug in it. On this one, you didn't have the height, so you have to find that.
Yep, so we had to do the Pythagorean theorem first to find what the height was.
See, I never heard the height theory.
Pythagorean theorem.
Theorem.
Well, and it's a good one to know because it is one that'll come up. Okay, so special triangles. What are triangles that all sides are equal called? Equilateral triangle, good. 2 sides equal. Isosceles. With a 90-degree angle? Right, yeah. Okay, so right triangles, what do you know? Go ahead, talk to each other, everything you know about a right triangle.
Okay, where does the c squared, a squared plus b squared equals c squared come from? That doesn't make sense.
We're going to cover that in a sec. Okay, let's see how you guys did about right triangles. Everything we know. It will have one of its angles being 90. The side opposite the 90-degree angle is always the longest. If you do Pythagorean theorem and you end up with one of your legs longer than the hypotenuse, something went wrong. Go back. Because if you think about it, if I have a 90-degree angle, what do these two angles add up to be? They have to add up to 90. So they both have to be smaller than 90. So they could be anything. If this one's 30, what's this one? 60. And the bigger the angle is, the longer the side opposite it. Since this is a 90-degree angle, the side opposite it has to be the longest side. The next longest side, because it's 60 in this one, would be this one, then the 30 would be that one. The angles tell you how, the order of how big the sides are going to be. Okay, so the other two angles must add up to 90. Whenever you see a right triangle, I want you to think Pythagorean theorem because I feel like that's always where they're heading. They're going to use it somewhere in there. They're going to require you to use it. Pythagorean theorem, we already talked about it. It is a squared plus b squared equals c squared. The hypotenuse is always c, and this is what it looks like. Doesn't matter if you switch the a and b around, but this is how you find. When you have two sides, you know, two lengths, is how you find the third length. Okay, quadrilaterals. Talk to each other. What are they? Give examples of them, as many as you can think of. Okay, so let's take a look. Squares are examples, rectangles, trapezoids, there are two parallel sides. So if there are two parallel sides, it means the other two sides are not parallel. So if I continued them, they would eventually intersect. So for example, I might have something like this, where these two sides are parallel. But then if I attach these, if I continued these lines, they're going to intersect eventually. But if I continue these, doesn't matter how long I continue them for, they're never going to intersect because they're parallel. So that's trapezoid. What is the sum of the interior angles of a quadrilateral? Do you agree with your partner? See if you agree with your partner. Let's do something fun. Okay. Since we've already got a triangle, what do the three angles add up to in a triangle? 180. What do the three angles in this triangle add up to? Okay, so then add them all together, 360. Quadrilateral will add up to be 360. Okay, go ahead with your partner, talk about how you're going to find the area of a square or a rectangle. Okay, got it? We all agree? It's going to just be the length times the width. With a square, the sides are all equal. So it's just the side times the side, and they're going to be the same number. The perimeter, same as a triangle, add up all the sides. This time we have 4 sides instead of 3. All right, let's go to circles. Define the following. Okay, go ahead and define it with each other. Okay, so radius, what is it?
Halfway through the circle.
Well, it's defined as going from the center of the circle to an edge of the circle. Doesn't matter where you do it. Any place from the center of the circle to the edge of the circle, that length is the radius. So then the diameter?
All the way through the circle?
Yeah, it's just 2 of those. Yep. It has to go through the center point, and then it will always be at the greatest distance. So these will be equal, even though imagine this is a perfectly drawn circle. It's a wonky circle, but pretend it's perfectly drawn. So that would be equal to that, and those would both be the diameter. Okay, so how about area? How do we find area? Area of a circle is equal to pi r squared. The circumference of a circle. What does that mean? What does circumference of a circle mean? Yeah, the distance around the outside of the circle. The area means all that space here that the circle takes up.
Ever called perimeter, or is that only space for polygons?
Yeah, it's for any poly-sided object. So triangles, yeah, I'm trying to think of
Just basically be
hexagon.
like 360, 180, 90 degrees.
For circumference?
Yeah.
So circumference is this distance. So if I drew a circle on the ground, if you had the right tool, you could measure the distance around that circle, right? So a distance can be measured in anything, centimeters, inches, but circumference The formula for circumference, does anybody know it? Yeah. Sometimes people say 2 pi r, but 2 of the radius is diameter. So that's the same as pi times diameter. Or the diameter times pi. You can switch them around, it's still the same thing. Okay. So if I cut up, right now I did cut this up a little bit. I've got 1, 2, 3, 4 angles. What are those angles going to add up to be? 360. Okay, so go ahead with your partner. Well, do it by yourself first and then compare. Find the radius of a circle that has an area of 144 pi. Okay, do you guys agree with each other on the answer? Okay, so we know that area equals pi r squared. In this case, our area equals 144 pi. Since it's on both sides, we can just cancel it, or you can just divide it out. If you divide both sides by pi, that cancels, that cancels. I'm left with r squared equals 144. If you came to the Monday workshop, this is one of those we should just know the square root of right away. What is the square root of 144? 12. So our radius is 12. We don't have a unit. We probably should have a unit. Centimeters, inches, miles. Okay, next question. Find the circumference of a circle that has a radius of 3 centimeters.
Don't you want the R under the 1 or the 12?
Over here?
Yeah.
So what I did was I took the square root of both sides. The square root of something squared is its opposite, so it becomes itself. And then the square root of 144 is 12. All right, so for circumference, we know circumference is 2 pi r. We have a radius of 3, so it's going to be 2 pi times 3, which is going to be equal to 6 pi. Agreed?
And they probably wouldn't make you multiply 6 times pi from the answer, or is it close to?
No, no. If they did, they'd say approximately what? So then it would be, yeah, times 3.14, yeah.
How do you find that?
So I know that the formula for circumference is 2 pi r. So the formula for circumference is 2 pi r. I know that the radius of my circle, which is r, is 3. So I just plug in the 3 for the r. It's 2 pi times 3 Multiply them together, I get 6 pi. Okay, let's move on to lines. Tell each other what the equation for a line is. You know it? All right. Two-dimensional thing. The Praxis doesn't really deal with that many three-dimensional things. It may throw in like one sphere question or one cube question, but if you know everything else, you're going to do fine. They don't publish it anywhere, but if you look online, it says you need approximately 60% or above on the test in order to pass. Okay, so anybody know the equation of a line? So if I had x equals y, that might be an example of an equation of a line. But then, so let me draw some things out here. I'll do 1, 2, 3. I'll do 1, 2, 3. I'll do -1, -2, -3. And -1, -2, -3. If x equals y, this is an example of a line. Then when I have x is 1, y is 1. When I have x is 2, y is 2. When I have x is 3, y is 3. So it is the equation of a very specific line. It's the equation of a line where my y-intercept is 0 and my slope is 1. Okay, so the equation of a line is y equals mx plus b. You guys ever seen this? I see some people smiling. I don't know if you enjoyed learning about this. It brings back good memories. Okay, so talk to each other. What is m and what is b? Tell each other what it is. Okay, so I hear some answers out there, and that's great. So m is slope. What does slope mean?
It's like climbing up a mountain.
Okay, so like climbing up a mountain. How do I find slope? What's the equation for slope? The change in y over the change in x. And that's the way I like to write it. I've heard that other people like it in a different way. I will write it in both ways. Some people like it y2 minus y1 over x2 minus x1. You seen that?
Yes.
Okay. What is b? Yeah, it's where the line crosses the y-axis. In this case, it was 0. That's why we don't have anything over here. When y equals x, our b is 0. So that's why there's nothing left over here. So this is, they call it the y-intercept, where it crosses the y-axis. So in our special line here, our b is 0. Our slope, we don't see an m because there's an invisible 1 out front here, right? Our slope is 1. Our y-intercept is 0. So this does follow the formula of y equals mx plus b. It just doesn't look like it. Okay. Let's apply this. Go ahead. Write the equation for the line that has the points 7, 2, and 5, -4. The which one? This for the slope?
Yeah.
Yes, you are going to use that. Yes. Did you guys find it? Ah, okay. Do you know how to find the B part? No. Okay. I'm going to erase this so I've got some work in room. Does anybody else want more time to work on it? All right, so let's look at this. Y equals mx plus b. M we said is our slope. It doesn't matter which of these we use first as long as we stay consistent. So the change in y, I can say 2 minus a negative 4 over the change in x. So I started with the 2, so this time I have to start with the 7. 7 minus 5. I'm going to get 6 over 2, which reduces to 3. My slope, my m, is 3. Did everybody get that far? Okay, so we found our slope. Let's write it in. Y equals 3x plus b. Now I just need to know b. How am I going to do that? Any ideas? Yeah. That's fine. You ended with negative 6 over negative 2? Okay. It should work either way. It doesn't matter which point you start with. Okay. Yep.
I thought 7 was the x to the 1 and 2 was the y to the other.
So when you write coordinates, the first one is always x, the second one is always y. X, y. So we have this. Any ideas on how we're going to move forward from here? How am I going to find b? I can use either of those points. Which one would you like to use? The 7, 2? Okay, so my y in the 7, 2, I'm going to use this point, 7, 2, because I know it's on my line. This is my y. This is my x. So 2 goes here. 7 goes here. Plus b. 2 equals 21 plus b. Subtract 21 from both sides. b equals 19. Negative 19. Now put it back up into here. And I have my answer. 3x minus 19. So this is the equation for that line. Does that make sense? Do you guys want to try it again?
I
Okay.
think I've done this before, but now I'm confused.
Okay, I'm going to erase all this. Can I erase all this? Okay. All that I'm going to leave up at the top is y equals mx plus b. Give me a point. Anybody? Give me a point. 4, negative 4. Okay, somebody else give me a point. Negative 3, 5. Okay, go ahead. Try to find the equation of that line. You guys picked a doozy. We get to deal with fractions too. See how much you get to compare. Oh, you put it in decimal form. I left it in fractions. If you leave it in fractions, then you get to practice what we learned on Monday about how to add and subtract fractions. How'd you guys do?
Still on the first part, kind of.
Okay. I'll wait. Did you get an answer? Did you leave it in fractions? Let's see. Ooh. Interesting. I got that part.
Okay.
Let me see what happened next.
I think I tried to do the 9 and, oh wait, maybe I was supposed to. I think I tried multiplying the 9/7 times 4.
Okay.
Oh, wait. 4 plus another times.
Well, let's work through it. So the first thing we want to find is m, which is our change in y over change in x. And we can do either one first. So if I do, let's see, I did -4 minus 5 over 4 minus a -3. So -9/7. Did you guys get that as your slope? Okay. So then now we have y equals.
-1/7.
Okay, maybe Jake, can you look at it and figure out why he got 1/7? I'm guessing you didn't subtract correctly, or maybe you added a negative. Okay, so -9/7 x plus b. We still need to find b. We can use either one of these. I use this one. Do you guys want me to use this one or this one? Bottom, the 3, 5? Okay. So then I'm going to have 5 equals -9/7 times -3 plus b. So I'm going to get 5 equals 9 times 3 is 27 over 7 plus b. I want to subtract 27/7 from both sides. So I'm going to end up with 5 minus 27/7 equals b. And this brings us back to Monday. Adding and subtracting fractions, what's the first thing we should do? Common denominator. So I need a 7 under this 5. In order to do that, I need to multiply by 7 over 7. So I'm going to end up with 35 over 7 minus 27 over 7 equals b. 35 minus 27, 8. So my b is going to equal 8 over 7, which makes my equation for my line, I'm going to write it over here, y equals m, we found is -9/7, x plus our b, which is 8/7. There's our crazy line. Did you use the other one? Use the.
I use this here. I'll show you this. So then I got the -9.
So let me see. Used. So where are we at? You're
I used the -3,
Okay.
so I typed in the -9
5, and then -3.
times -3 would be 3 6/7.
Explain to me
This
what you did
one?
here.
Multiplied those two.
9. Okay, but what's 9 times 3?
27.
27 over 7.
Oh, okay. Just leave it like that. Okay.
Mm-hmm.
I feel like I got it.
That make sense?
Yeah.
Okay.
Can it not work, like, if I'm on the test and have to type it in like that? Would that not work then?
I'm not sure what you were typing in.
Just the -9/7 times this.
It should still work.
I don't know why it did.
Did you put parentheses around the -9/7? And what does that mean? What is that using? I don't know what that means.
Just 3 6/7.
But the 3 6/7, which would be 3 times 21 plus 6 is 27.
I guess that would just be an
Sevens. Yeah.
easier method.
But I think it still works. Is that because 3 6/7? Go ahead and write down 3 6/7. Write it down here. If you were to change that back, you would multiply 3 times 7, which is 21, and you would add 6, which would be 27 sevenths.
Okay.
So it's the same thing.
Okay. Sounds good.
So
5 equals 27/7 plus.
B.
Okay. And then I know how to figure
Yep.
the rest out.
Okay, are we ready to move on? Okay. The distance formula, what is it and when do we use it? Jake has it written down. Okay, did you guys talk to each other? Do you know what the distance formula is? When do we use the distance formula? Anybody? No? Okay, a lot of silence in here. So say I've got a dot here and I've got a dot over here. I want to know what the distance is between these 2 points. I want to find that distance. I don't have a little tape measure to measure it, but what I do have is I have coordinates that I can use to measure. Okay? So has anybody used the distance formula? Yeah? Okay.
Would you just take the biggest number subtraction and the smallest number?
So let's see, I'm in this quadrant. So say I am at 2, -2. And let's say over here I'm at, I don't know, I'm at 10, 10. How do I find the distance between those two? I've got 4 numbers.
Would you subtract 10 from and subtract it to the -2?
Subtract 10 minus 2?
Yeah.
If I subtracted 10 minus 2, that would tell me how much I've changed on the x-axis, sure. So that tells me that that's 8.
Yeah.
Okay. How do I find the distance of that? Oops, 10 minus.
Couldn't you go down 10 spaces and just added up the -2 or something like that?
You have the right idea. Because wait, I'm going, so I know that that's 8, because I went from 2 to 10.
Because it's 12 spaces.
So how many spaces did I go here?
Would you go up 12 spaces then?
Okay, good. So I went up 12 spaces. But what do I want to know? Do I want to know this leg or this leg? I want to know the distance. I want to know this one. What do we have here? We have a magical
Triangle.
right triangle. Ding, ding, ding. So how do we find the length of a leg on a right triangle? The distance formula is made from the Pythagorean theorem. They use the Pythagorean theorem to find the distance. So it's an ugly 12. Sorry, I'll fix it. So in our hypothetical here, we should be able to find what that is. You guys want to try?
Is it a long formula?
It is kind of long. You think you know what it is?
Yeah, I wrote it down, I just don't know if it's like.
But the way he was mentally visualizing it is basically what they're doing with that formula. So it's cool to know where that formula comes from. We have our a and our b. A squared plus b squared equals c squared. A squared plus b squared equals c squared. What's 8 squared? 64. What's 12 squared? What's 64 plus 144? 208? Did I make that up? What's the square root of 208? Okay, I'm just going to leave it as the square root of 208. Okay, so we found it that way, but you can also use the formula. All we did was look at the difference between 10 minus a negative 2, which we got 12 from, and then 8, and then it's squared. Same thing we did. So 10 minus a negative 2 is 12, and we squared it. And then we did x2 minus x1. So x2 minus x1 is 8, and we squared it. And then we took the square root of it to find the distance. We used the Pythagorean theorem.
Well, where does the square part go? That's my question. Where does the square part come into all this? Because there's nothing in previous, so where does it come from?
Where does this come from?
The square parts, yeah.
That would be a proof of the Pythagorean theorem.
Because it doesn't just come out of thin air, though, I feel like.
I think we have to look up a proof of the Pythagorean theorem for that. Okay, I want to give you guys time to work, so I'm going to skip ahead a little bit. And skip to probability and statistics. Can I erase this? Yeah? That Pythagorean theorem pops up everywhere. Just have it ready to go in your head. Okay, graphs and tables. We have bar graphs, line graphs, circle or pie graphs. Be able to work with them, understand what they mean. If you have graphs in your other classes, take time and look at them and try to understand them. So one of the things that I found the most that surprised me on the Praxis was asking for trends. They would give me something like this, and they'd be like, as x increases, what happens to y? So as x increases, what's happening to y in this graph? It decreases. So understanding those relationships is really important. Okay, can you guys read that? I will read it to you. I will draw it. So the circle graph above shows the distribution of the Chang family's vacation budget over 5 categories. According to the graph, for how many of the 5 categories was the dollar amount of the budget category greater than $1,000? So what they have here is they have a pie chart, and they're saying that the Chang family spends 40% on food. They spend 10% on transportation. They spend, 12% on entertainment. And they spend 3% on other. And then lodging is 35%. they say that the total budget for their vacation is $3,500. So they're asking, according to the graph, for how many of the 5 categories was the dollar amount of the budget category greater than $1,000? So your choices are 1, 2, 3, 4, or 5. So for how many of these categories was the budget amount over $1,000?
How much do they have altogether?
$3,500. So go ahead and try it. See what you get. So they're saying this is how they broke down what they spent. This is their total budget. For how many of these categories did they spend over $1,000? Okay, so I don't have a calculator in my hands. How much did they spend on lodging? Exactly 1,000?
1,245.
How did you find that?
I did 3,500 times 0.35.
Good. 3,500 times 0.35 should give you the amount. I'm going to trust you on the amount. So then how much did they spend on food? 1,400? Exactly? Okay. How much did they spend on transportation? Okay, 350. How much did they spend on entertainment? 420. Okay. So as long as you know how they're getting these, how many of these categories did they spend over $1,000 on? 2. Okay. All right, let's go to the next question. I think I may have to draw this one as well. So there's a triangle in an XY plane. It's going to be translated 3 units to the right and then 2 units down. What point will correspond to vertex A after these translations? So let me try to draw the graph. Okay, so we have an XY plane, XY coordinates. We have a triangle that is over here. We need 1, 2, 3 lines. And over here we need 1, 2, 3 lines. I've got 1 here, and 1 here. Okay, so I have vertex A, vertex B, and vertex C. It said they're going to translate this 3 units to the right and 2 units down. They want to know, where is vertex A going to be after the translation? So go ahead and find it. Find it? No, and they're going to do a lot of these. They'll have something drawn, and they're going to say, it is reflected over the y-axis, in which case you have to imagine it being reflected over the y-axis, or it's going to be reflected over the x-axis, or it's going to be rotated around the midpoint 90 degrees clockwise, or 180 degrees counterclockwise. So 90 degrees clockwise, it's going to come over here. 180 degrees counterclockwise, it's going to come over here. Am I going the right way? Yeah. And I'm sure there are equations for it. Okay. No, most of them you can figure out by these kinds of steps. Okay, so what did you guys get? If I move, what is vertex A starting with? What is it? Okay. -3, 1 is the vertex A starting with. I'm going to move it 3 units to the right. What's it going to become? It's going to become 0. I'm going to move this one 2 units down. What's it going to become? -1. So my new vertex A is going to be at 0, -1. Okay, probability. For probability, answers will always be between what 2 numbers? 0 and 1. Because there's a 0% chance to a 100% chance of something happening. You can't have more than a 100% chance of something happening, right? So the probability of something happening is 0 to 1. It's somewhere in there. It's from, if I change those numbers into percents, it becomes 0% to 100% chance of something happening. And it has to range in between there. It can't be less than a 0% chance. It can't be more than a 100% chance. So if you get a number that's less than 0 or greater than 1, something's probably, go back, check your math. Be careful with and or questions. So if there are 5 red marbles, 6 blue marbles, and 10 white marbles, what is the probability that we will pull a blue marble out of the bag? Go ahead and try it and talk with each other. See if you agree with your partner. Leave it as a fraction or as a ratio. So what chance do we have of pulling out a blue marble? 2/7. 6 over 21 can be reduced to 2/7. Okay, there are 5 red marbles, 6 blue marbles, and 10 white marbles. Same situation. What is the probability that we pull either a red or a blue marble out of the bag? What did you guys get as an answer? 11/21. It's the chance of pulling a red marble, 5 out of 21, and the chance of pulling a blue marble, 6 out of 21. Add them together, you get 11 out of 21.
If you want to go for, isn't it asking for percent?
You can change it to a percent. What is the percent? What is 11 over 21?
52%?
Okay, 52%. And 52% written as a decimal is what? 0.52. Is it between 0 and 1? Yeah. Okay. There are 5 red marbles, 6 blue marbles, and 10 white marbles. What is the probability that we pull a blue marble out of a bag on the first draw and a red marble out on the second draw? Okay, let's take a look at it. So let's look at the first situation. What's the probability that we're going to pull a blue marble out of the bag on the first draw? Okay. Sure, 2 7s. You can also write it as the original if it's 6 out of 21. 2 7s. Okay. So if we have 2 7s, what's the probability that we pull a red marble out on the second draw? Because it's 5 out of 20, right? So what do we end up with? If we have an and means multiply. Or means add. So, in probability. So in that second question, it says, what is the probability that we pull either a red or a blue? We add those two probabilities together. When it says, what is the probability of this and this happening? We multiply the probability of this one and the probability of this one. So what is the probability going to end up being? Yeah. If we multiply with fractions, we can multiply across. We do not need a common denominator. So we're going to end up with 2 over 28, which can be reduced to 1 over 14.
So that means you add up when or multiply on? So
But-
multiplying is when they say and.
Multiplying is when they say and,
Adding is when.
they say or.
So that's sort of like a lower probability, and it's logically makes sense. And then a higher probability is for or makes sense because like even though the back.
Yeah, so the chances of it going up, like what's the chance that you have your name in a lottery and what's the chance that you win a $20 prize or a $5 prize? Your chances are going to go up than just the chances of winning only a $20 prize and a $5 prize. It's going to make your chances go down. So when you multiply these numbers, that denominator gets bigger, which means that you're dividing by a bigger number. The whole thing's getting smaller. Okay, probability. I think we have another small question. I wonder if I can make this guy bigger. Let's see if I can make it way bigger. There, okay. Let's see if we can see it. Oh. There it is. Can you guys all read that? It's cut off a little bit, but it's if one individual is to be randomly selected from the group, what is the probability that the individual selected will be a woman? This is actually one of the sample questions that the company ETS published. So this is one of the questions from the company that makes the actual test. Okay? So what did you guys get as an answer? 3/8. Good. Okay. Does anybody have a question on how we got that? No. Okay, place values in scientific notation. Place values. What are the place values in the following number? Talk with your partner and see if you agree. What's the place value of the 3? What's the place value of the 6? What's the place value of the 8? So one question I think that this will be part of a question. This probably won't be a whole question. It might be something like, if I have this number and I multiply it times 10 to the second and divide it by 7, what is in the 10th place? So it's going to be a little bit more complicated, but it starts with knowing these place values. So what is the 4 in? Ones, 8, tens, hundreds, thousands. What's the point? What's the 2? Tenths with the TH at the end. And then 6? Hundredths. There is no such thing as a once. And I think that trips some people up. So there's the place values, the decimal point, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Okay. This is another example that's published by the company. So it says when 641.29 is divided by 10, which digit of the resulting number is in the tens place? So when 641.29 is divided by 10, well, I'll write the number up here. 641.29 is divided by 10. Which digit of the resulting number is in the tens place? So when I divide by 10, what's going to happen? It's my new decimal point place.
It just moved over one spot.
Yep. So what's in the tens place now? The 6. This is in the tenths. The tens. So this one's tens place. Okay, scientific notation. Which of these is not in scientific notation and why? We have 1.2 times 10 to the third. We have 5.3 times 10 to the ninth. We have 2.0 times 10 to the 0. And we have 10 times 10 to the second. Which of these is not in scientific notation and why?
2.0 times 10 to the 0.
That is in scientific notation. Which one? The last one. Why is that not in scientific notation?
A point is missing.
We need a decimal point to go there, which is going to make it 1 times 10 to the third. Not 10 times 10 to the third, 1. Scientific notation does not need a decimal, but it cannot be a double-digit number in the front. In front of, it could just be 2 times 10 to the 0. It could be 5 times 10 to the ninth. It cannot be 53. This first number, this number that's in front of the decimal, must be between 0 and 10. Not including 0 and 10. What's that? Statistics? Yeah. They do have I did have scientific notations. Has anybody else taken the test and had a scientific notation question on your test? Yeah, it's on the test. So to make this in scientific notation, I can't have 64. I need the first number to be between 0 and 10, not including 0 and 10. So this in scientific notation, so if I started out with my original number of 641.29, I would have to move the decimal point behind the 6. And I moved it 2 places, so times 10 to the 2. The decimal point must go behind that number. The number in front of it must be below or between 0 and 10, not including 0 and 10. Okay, let's try. Go ahead and try it. What is 0.01096 in scientific notation? Talk to each other first. See if you agree. Okay, what do you guys think it is? Not unless it asks you to. 1.0, I'm going to keep the 96 there, times 10 to the negative 2. Good. You got that negative 2. The reason it's negative 2 is because I moved it this way. Okay, let's try some more. Oops. Okay. Try those last two and compare with each other. What is 9.3 times 10 to the negative third in standard form? It's already in scientific notation. Put it into standard form. What is 3,521 in scientific notation?
You wanna move it to the left, right?
Right?
With a comma in the last one?
Yeah, it's a comma. 3,521.
Yeah, no, I thought.
Kind of small up there.
So negative equals right?
Negative means I'm going to make that smaller. So 9.3 is going to become a smaller number. So I'm going to move that 1, 2, 3 places. Okay, so your first answer should look like that. What did you get for the second answer? 3 point. 10 to the 3. It's going to be positive 3.
Is there a way you could write 2.5
It's already times 10.
Oh, let's say that it started off with that number.
Okay, sure. So if I had, I'm going to make it a separate question so we don't get confused. If I had 3.521, it basically already is in scientific notation. You could write times 10 to the 0. Because anything to the 0 power is 1.
Oh, I didn't think 0 plus 1. Okay, we were thinking that would make it 0, then times 0 would be 0, which would cancel the 30 there.
No, anything to the 0 power is 1. Okay. All right, mean, median, mode, we covered it last time. It was actually supposed to be in this section in statistics and probability. So go ahead and see if you remember it from Monday if you were here. Define what mean, median, and mode are to your partner. Go ahead and talk to each other. Do you have a question?
Yes.
Okay.
Wouldn't the point be here? So you go 1, 2, 3.
Yep.
But you put 0 though.
Put 3.51 times 10 to the third. That's my, this is a separate question. This is the answer. Yeah.
The highest minus the lowest.
Yeah.
I just learned that.
Yep. Yes. Range, I didn't write it up here. Range is how big is the range? Like, you know, if you have a brother that's, well, Jake, we'll use it as an example. How old is your youngest sibling?
16.
How old is your oldest sibling? What's the range? So they have a range of 16 years. Ooh, we could use your whole family as an example. Okay. Okay, let's do mean, median, and mode on Jake's family. Okay. So can I have all the ages of all of them? You don't need to put them in order.
15, 15, 23, 25, 25.
Ooh, this is going to screw us up for mode, but that's okay. And 30. Okay, there you go. Find the mean and median. Mode's going to be a little bit harder. There are 2 modes. Okay, so we already determined that the range was the highest minus the lowest, so 32 minus 16, which was 16. Okay? When you guys found the mean, let me know. Okay, I'm taking your word for it. You guys are going to have to correct me if she's wrong. You guys agree? The mean, the way we find mean, it's the average. We add them all together, and we divide by the number of them. We have 1, 2, 3, 4, 5, 6, 7. Add them all together, divide by 7. Do you get that? Yeah? Okay. What's the median? Is it 25? Let's go from both sides. 32, 16, 30, 16, and then 23, 25. Yeah, well, 25. Okay, what's the mode? Yeah, he's got 2 of them. He's got 2 sets of twins in his family. All right, so that was a revisiting of mean, median, and mode. I think. So here's another problem from the company. I want to see if I can make it bigger so you guys can see it. And I feel like this is a question, this form of question, they ask a lot. It's a slight switching on the traditional question of mean. So the numbers of absences in Mrs. Klein's class for each of the first 3 months of the year were 16, 12, and 17, respectively. If the average or arithmetic mean number of absences for the first 4 months of the year was 14, how many absences were there in the 4th month? Yeah, it is. Do you guys find the answer? Does anybody, who knows how to find the answer? How do we find a mean? How do we find an average? Add them all up and divide by 4. Okay, let's add the first ones up. 16 plus 12 plus 17. What is the 4th month? We don't know what it is, so we're going to call it X. We divide by 4 because that's how many months we have. What's the mean? What's the average? They already told us. 14. Can you solve for it now?
Add the 3 up and subtract one side from the other.
Okay, go ahead and try it. I think we only have one slide left after this, and then we get to practice. Okay, so I think I got 45 plus x equals 56. Subtract 45 from both sides. X is going to equal 11. Okay. Okay, let's go to the last slide. Taking a survey. I feel like this is another question that is on almost every test. They look for one that has the least bias or the most bias. So for example, which of these is the best way to learn how UWSP staff feel about Wisconsin weather? Interview 20 geology professors at a department meeting, stand outside on a minus 20-degree day, and ask a group of staff members who are making snowmen. Ask every 5th member who enters a UWSP building until you have asked 100 people. Ask every 10th staff member who is standing by a heater in the basement of the library until you've asked 25 people. What do you think? The third one, okay. So always look for the highest number of people surveyed. Make sure that they're surveying a group that isn't one specific group. In this first one, they're at a geology professor meeting. That's a specific group. You want to spread it across. And then you want to be random every 5th, every 10th, okay? So make it random. All right, so go ahead. Let's do practice time. Jake and I will be around to answer questions. So, yeah.
So just like this last one, so we added that up. So that's how we got our 45. Did we subtract the 4 onto this side? For it to
Multiply both sides by 4.
Okay.
Because you want to get rid of that 4, right? So if you multiply both sides by 4.
Why didn't anything change when I multiplied that by 4?
So you're multiplying the whole thing by 4.
Okay.
Those 4s will cancel.
Okay.
And you multiply that side by 4.
Okay. My other question is, so yesterday, I just really want to see this again. Yesterday, you did that one problem with the graph, and we had to decide, like, what percentage.
Okay, let me look for it.
Okay, I know it's going to be on that test tomorrow, and I really need to see it.
Okay,
I want to.
let me try to find it.
Okay.